All right, so let's get started. Continuing to the previous session.
Okay.
So we already discussed about the host-to-host layer. As I told you, in OSI model, we have transport layer. In TCP/IP, we are call it as an host-to-host layer. So in this layer, we have two protocols, TCP and UDP, which we have already discussed before, right? But again, the difference between TCP and UDP. TCP is connection oriented, UDP is connectionless. TCP supports three-way handshake, where UDP does not, even does not need as well. And TCP supports windowing, where UDP does not, and TCP supports flow control. So these are the
Why it's called connection full and connection less?
no, the connection oriented and connectionless. Connection oriented because if you remember, before sending the data, it will create a session
Okay.
between source and destination.
Okay.
And
So basically, it creates a platform, a session where it will make sure that like doing a three-way handshake and authentication and everything.
correct.
Okay.
And the next layer is internet layer. In network layer in OSI model, the third layer is called network layer in OSI model. It is called internet layer in the TCP/IP model.
Then in host to host is only one. Host to host only has TCP and UDP or something else also.
Only two protocols, TCP and UDP.
Okay.
Right. So in internet layer, we have the other protocols which are working in the data link. Sorry, in the network layer, the protocols like IP, ICMP, address resolution protocol, and then reverse ARP. All these protocols work at the network layer, or you can say the internet layer.
Which is the ARP table and everything, right?
Correct.
Okay.
Right. So what is address resolution protocol? Anyways, we haven't discussed as of now. So what happens whenever the communication happens in the LAN, right? In that case, sender should have the receiver MAC address. Sender should know what is the MAC address of receiver.
Okay.
By default, they don't know. Whenever you connect the devices newly, right, in the network, they won't be knowing what is the MAC address of the destination. They know the IP address, okay, the layer 3 information they know.
Okay.
Right, but MAC address they don't know. So let me draw one diagram and see if so let's say this is a switch, and from switch I have two computers connected. These are the two computers. Very bad handwriting. Right, and the IP address of this machine is 192.168.1.1, and the IP address of this machine is 1.2. MAC address, let's say A, and MAC address B. Now this computer knows what is the IP address of this computer, right? But initially this computer doesn't know what is the MAC address of this. So now this computer to learn the MAC address of the this computer, it will use address resolution protocol ARP. So it will send ARP broadcast where the source IP will be its own IP, source MAC will be its own MAC address, destination IP will be 1.2, and destination MAC will be the 12 times FF. FF means this is a layer 2 broadcast address actually.
Okay.
So when this particular format goes to the switch, right, switch will check, okay, what is the source MAC? The source MAC is A, right? Now switch will add this information in CAM table. Let me, where is this? इसका pen कहाँ गया? It comes little late. So
The router keeps the arc table, right? Not the switch.
no, I'll come to that. I'll come to that. Right. So you got it right. So now when the request comes to the switch, now what switch will do? Switch has got actually the primarily functions like address learning. I mean, there are three functions used by switch, like address learning, है ना, forwarding, and the third is loop prevention. These are the three actually function of the switch, basic function. So in address learning, what happens whenever switch receives the frame, it will open the header, layer 2 header, right? And we'll check what is the source MAC. So in address learning, it will learn, okay, the source MAC address, let's say A is there in the port number F0/1. Let's say this is the port number F0/1. This is the port number F0/1, and this is the port number F0/2. So what switch does, switch maintains the CAM table, right? This is how in that CAM table, the interface information will be there, means what is the interface, and MAC address information will be there, what is the MAC address, and we will have the VLAN ID information. So let's say this is F0/1 and this is F0/2. And as I told you, here we have VLAN ID. By default, the VLAN of each port will be 1. Right? So even the port of the VLAN of F0/1 and 2 will be 1. But switch doesn't know this table, this information, MAC address. By default, the CAM table, this CAM means content address memory.
Content?
Address memory.
Okay.
Right? So this CAM table will be blank. Now, there won't be anything in this CAM table initially. Now when switch receives this particular frame, it will open the layer 2 header and will check, will go through this process, function, address learning. Switch will get to know, okay, the address of this machine on this port is A. So it will keep that information in its CAM table. Right? And then second is forwarding. To forward, it will check what is destination MAC. The destination MAC is in this case 12 times FF. Exactly the size of MAC address, which will be 48 bits.
But
right?
it doesn't know the MAC address.
No, it doesn't know that. FF means layer 2 broadcast. Now switch, what it will do, it will forward. Switch knows that, okay, since this is layer 2 a broadcast address, I have to forward it to all the ports. So except this port where it was received, switch will forward to the rest of the other ports. Assume I have one more computer here and the IP address of this is 1.3. Right? So in this case, now switch, what it will do, when it forwards to all the ports, let's say 1.3 receives, when it opens the header, it will check source IP, source MAC, destination IP, and the destination IP this computer will find as a 1.2, who is, and this guy is 1.2. So this computer will drop that packet because this message is not for 1.3, it is for 1.2. But when 1.2 receives here, what it will check, okay, since I am the 1.2, so I have to reply of this message. So this computer will reply to that request.
Mhm.
So in that case, source will be this computer and receiver will be this. So it will add source IP, its own 1.2, source MAC B, destination IP 1.1 and destination MAC A. Because now this computer knows what is the MAC address of 1.1,
Mhm.
right? When again this message comes to the switch, goes to the switch will open again IP header. When it opens, it will check who is source MAC. Source MAC is B, and which is present in the port number F0/2.
Mhm.
It will keep that information in CAM table and then check what is destination MAC. Destination MAC is A. Now, before sending, switch will scan its CAM table and check, do I know where is MAC address A? And in this case, yes, MAC address A is on port number F0/1. So this switch, instead of sending broadcast, it will send unicast packet to port number F0/1.
Mhm.
And this computer will receive that message and will get to know that what is the MAC address of 1.2. Now, since this computer knows the MAC address as well as IP address, it will be able to communicate.
Now, what my question is, so when the switch receives the first time,
Mm-hmm.
uh, uh, when it receives the message from number A, the first router, um, and you
Computer.
say it opens the IP header.
Mm-hmm.
So why not the Ethernet? Why not the frame? And why the IP header? Because IP header is for layer 3, but switch is layer 2.
That's why switch will open the layer 2 header.
No, IP header is layer 3 header, right?
Correct.
So it should open the frame layer 2 Ethernet frame header, right?
Yeah, that's what it is opening. This computer, anyways, from this computer, the complete OSI information will be there. All several layers information will be there with any all request. Right. When this information goes to the connected device, now it depends which layer that device works. So since this switch works at the layer 2, so instead of checking source IP, destination IP, what it will check, it will open the layer 2 header. And in layer 2 header, what it will get? Source MAC and destination MAC.
Mm, right.
Right. So after opening layer 2 header, it will get to know what is MAC address and all.
Okay, so where did the IP header come in the picture then?
As of now when communication happens, since the communication is happening in LAN, right? And in LAN, the complete OSI model anyways will be added to the particular any request. But since this switch is least concerned about the IP addresses, when switch is working in the MAC addresses only, then why will it open the IP header? It will open just MAC address layer 2 header and send the traffic to.
Yeah, I think I heard that maybe I misunderstood that when the first time the device
Mm-hmm.
uh, is trying to connect and through the router, when the switch receives a message from router A,
Mm-hmm.
it will open the Ethernet header, not the IP header, right?
Correct. Ethernet header.
Okay, and it will just get the source and the destination MAC, but the
Correct.
destination MAC will be empty with FFFF,
Correct.
so it will do the broadcast.
Exactly.
And when it returns, it will when it gets the return message from the acknowledgement of say um, number 1.2,
Mm-hmm.
it will again open the Ethernet header, or it will now open the IP header.
No, every time it will open Ethernet header only.
Okay, so who will open the IP header then?
When the traffic goes to the router, now this is router connected to the switch, right? And here it is the connection is going to the service provider. Now this is your service provider.
Hmm.
When the connection now you are trying to ping or you are trying to communicate outside, then the router will receive the traffic. As of now you
Okay.
were communicating internally, so router wasn't receiving. Since now you are communicating outside, so router will receive and router will open IP header.
So the box where you have put letter A
Mm-hmm.
in the square box after the triangle device, no. on the diagram.
Okay.
Letter A right there. Is
This
that
one.
a router? No, down,
No, these
down.
are the computers.
Okay, and
It's
then
this
then
way.
then the box above the computer where the letter A is.
This one.
Yeah, that one. That is a switch or a router.
No, this is computer.
Oh, okay,
These are all computers.
okay, okay.
Right. Now, this actually cam table is maintained. Switch will maintain the cam table and it will keep all the information in its cam table. If the details are there, the MAC addresses are there, switch will send unicast, otherwise it will do broadcast.
Mm.
And the idle time of maintaining this cam table is 5 minutes or 300 seconds. Means if in 300 seconds, if switch doesn't receive any response from any MAC address, let's say this MAC address is idle more than 5 minutes,
Mm.
what switch will think that this MAC address is no more exist.
I see.
So this MAC address will be removed from its cam table. Why? Because if it keeps on learning the MAC addresses and keeps on keeping all this information in cam table, the cam table will itself will be very big, and
Mm.
all idle information will be there.
Right.
Right. So switch removes all idle information. The idle time is 300 seconds. After 300 seconds, if it doesn't receive any response from any of the MAC address, it will remove.
Okay, it will remove A, B, everything if it does not receive anything for 300 seconds.
Correct.
Okay.
Right. And then loop prevention. Loop prevention we'll talk about in later sessions.
Okay.
So that is how the ARP request address resolution protocol works.
Mm-hmm.
All right. And reverse ARP is just opposite of your ARP. Right. So in ARP, IP to MAC resolution happens, right? And in reverse ARP, MAC to IP. They're just opposite of ARP.
And where does the ARP table is saved? In where? Which device is the ARP table saved?
All devices save the ARP table. In fact, computer will also save the ARP table. Switches will also, router will also, because router will also have layer 2 port, right?
Mm,
LAN ports, Ethernet ports, router will also have.
okay.
So all devices will maintain the ARP table.
Mm-hmm.
All right. The another protocol in this internet layer is ICMP, Internet Control Message Protocol. ICMP protocol is basically used when we check the connectivity using the ping,
Right.
right? So what happens? ICMP protocol, it tells you the status of the protocol. What happened to the it tells the status of the packet.
Okay.
So what happened to your packet, the one which you sent in the network? What is the status of that packet? Everything. This is the status of the packet will be displayed by the ICMP.
Mm-hmm.
So like destination host unreachable, request timeout, or we are getting reply. That kind of messages will be generated by the ICMP.
Okay. So my question is, when we receive all these messages, I see this on a regular basis when I try to ping the servers.
Mm-hmm.
So can we tell exactly from the message what the issue may be? Like, because there are different messages, right?
Mm-hmm.
Host not responding, or the connection timed out, or something like that. So is it possible that just reading those messages, we can have an idea of what is wrong or what may be wrong?
Yes, we'll talk about anyways. This is there in the syllabus, and maybe after a couple of classes, we'll talk about all ICMP and all the troubleshooting things.
Okay.
So it is there. We'll talk about step by step. But yes, these
Okay.
messages will have the significance meaning.
Okay. 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 That's it. That's good.
All right. So moving from network layer or internet layer to the network access layer. In this network access layer, OSI model, physical layer, and data link layer, two layers have been combined in TCP/IP model and called as a network access layer. Right.
Um,
So
internet layer, and then it should go so session, uh, transport, and then I'm confused.
No, so we have already discussed about the
The
process
first three:
application.
application, presentation, and session,
Mm-hmm.
and then
Transport layer,
session, then it is transport in host to host, transport. Then third is internet, and
network
then
layer. Internet
oh,
is called network layer in OSI model.
okay, and then two remains, right? Data link and physical.
Yes, so both combined as in called here in TCP IP as in the network access layer,
Network access layer. Okay.
right? So in this, the protocols are like SDLC, triple P, frame relay, ATM. These are the protocols used. We'll talk about, we have WAN protocols, a separate session, in fact, separate chapter itself. So we'll
Hmm.
talk about these protocols later.
Okay.
Right? But these are the port ranges which we discussed, that in transport layer it adds the source port and destination port, right? So these are the few examples of all the services, all the protocols which they use the protocol, the port numbers. So like ICMP, it uses the port number 1, IP 4, TCP 6, UDP 17, right? And like telnet uses port number 23, SSS 22, SMTP 25, STTP port number 80, NTP 123, DNS 53, TFTP 69. So these are the DHCP 67. These are the different actually port
Yeah,
number.
I have a very simple question in that Word document I sent you.
Mm-hmm.
Uh, like, what exactly is the port? I get so much confused because you will have the port on the server, you will have the port on the switch, you will have the port on the router. So how are these coordinated? How are these standardized, streamlined, or
No, so
it's
in the in the port numbers in the routers and switches, right? They are the physical port ID, right?
okay?
We have the interfaces, we have the ports, right? Each port will have the port ID. For example, switch. In switch, we will have some, let's say, 24 ports, right?
Hmm.
Now 24 ports, if they are the fast Ethernet, if their capacity is 100 Mbps, they will be normally called as in the fast Ethernet.
Which is they can use fiber channel or no?
Fiber channel they can use, but they need the different type of connectors.
Hmm.
This SPF, SFP, and all these are the different connectors actually.
Hmm.
But yes, right. So these fast Ethernet ports, they will have the ID like fast Ethernet 0/1, 0/2, 0/3, 4, 5, like this,
Hmm.
right? They are the physical port ID,
Okay.
right? And same in the router as well. We'll have
Okay. So
0/0, 0/1.
okay. So F01, F02, these are the physical slots where
Yes,
where the cable is inserted on the
correct.
and the switches.
On the
So
switches or routers, correct.
and the ports on the server, which we say that, oh, your this port 22 is blocked. When I ran nmap, I see port 22, port 22 is filtered, which is there is a rule that's blocking it. So
Mhm.
what does a port mean when it comes to server then?
All right. Now every service will have a port number. Any service, for example, whatever you are doing in the laptop, right?
Hmm.
There will be a protocol behind that service. So, for
Okay.
example, just tell me anything that which you are doing in the laptop.
For example, SSH.
SSH. Let's say you are accessing the device through the SSH,
Right.
right? The port number. So, okay. Now, SSH has got the port number 22.
Correct.
So, whenever you initiate the request, source port will be, as I told you, source port will be always between this. This is the private or dynamic private ports. So each and every new request will have a source port number and destination port number. Source
Hmm.
port number will be random port number, anything. But in this case, destination port will be always 22. because which service you are going to use, how to describe or how to know what kind of service you are using. For example, when this request goes to the transport layer has to identify what is the application being used, what is the service being used, right? So this transport layer will say, okay, since it is SSH, means that for SSH the port number is 22, right? So it will use port number 22 because you are using the service of SSH, right? So source port will be random port, destination port will be 22. Let's say
Okay.
you are browsing now, you'll open Firefox or Safari and you are browsing. So browsing is, which means the service
80.
here is used as an HTTP. The protocol is HTTP. As I told you, behind whatever you are doing, there is a protocol, right? The protocol will be working. So if you're browsing anything, in that case, the protocol is HTTP. Now, what is the port number of HTTP?
80.
In this case, 80. Right. So the transport layer will add the source port as a random port and the destination port as an port number 8.
Right. So because in the server there are no physical port slots, so these are just the services.
These
This
are
is
the
just
services port.
ID given to the services basically.
Correct.
Okay.
Services port.
Okay.
Got it.
Yes. So
All right.
basically it's saying that this certain service or certain protocol is blocked by the firewall. Just open the connection for this service so it can restart.
Correct. Because what happens when we talk about the firewalls, right? By default, it will block all the ports. Now, if you are trying to actually, create a session, or if you're trying to access something which is blocked in the firewall, which means ultimately that request is not going to the destination,
Right.
right? So you have to unblock that port.
Okay.
All right. So that's about these are the protocols anyways. These just protocols, you can go through yourself. Some of the protocols we have already gone through anyways, like file
Okay.
transfer protocol, APIPA. We'll talk about APIPA anyways, but automatic private IP addressing. Normally this protocol is used when you have set your computer to get the IP address, to obtain the IP address automatically.
DHCP, and when the DHCP server does not, for some reason, when it fails, then the computer will get its own automatic IP temporary to keep connection.
Correct. So at the end, computer needs IP address. It will obtain the IP address within this range. This range is
Right. And
called
how about the TLS and SSL, the layer?
correct. NFS network file sharing. This is for the file sharing. So whenever you share the file from maybe one computer to another computer, in that case the NFS protocol will be there. SMTP, simple mail transfer protocol, for the sending an email. POP3 for receiving email. IMAP for the Outlook and all. And a TLS, transport layer security, for the
So
cryptographic
that,
protocols.
so that how are these protocols covered, or where is that covered? The
No,
TLS and SSL?
these protocols are not there. It is just like, the introduction of these protocols. It's good to know.
Okay.
And then like session initiation protocol, it is used for the voice and video calls. RTP for the delivering audio and video, right? And SNMP, simple network management protocol, gather the information by polling the devices. SSH, HTTP, HTTPS, NTP, network time protocol for time synchronization. And NTP, news transfer protocol. SCCP is just like your FTP, but it is more secure copy protocol,
Right.
right? LDAP, lightweight directory access for the Active Directory access. ICMP, internet control message protocol discussed. DNS, domain name system, which resolves the name into IP address. Right? These are actually the protocols. All right. The next is IP addressing. So we have IP addresses. Let me open new. Alright, when we talk about this subnetting and all, so it's very good and very important to know IP addresses,
Okay.
the basic IP address range and all.
Mhm.
So what is IP address? As we discussed earlier, Internet Protocol. This is 32-bit actually the logical address which provides the unique identification to the devices globally, right?
Mm.
So how the IP addresses actually the channel works, the 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 whole range of the IP addresses, because there will be a range. We'll discuss about that range, but there will be a range. So a whole range of the IP addresses, the control of this particular range will be with IANA,
Mm.
Internet Assigned Network Authority, or ICANN. So they will have the full control of the IP addresses. There are two types of IP addresses. One is public IP address and the private IP addresses.
Mm.
Public IP addresses are routable to the internet and can be accessed by anyone, like google.com, yahoo.com, networkstm.com, cisco.com. These are the public IPs.
Okay.
Anyone can access, right? But private IP addresses are used by the enterprise within a company,
Mm.
and no one can access because no one has got idea what you are using in your company inside,
Mm.
right? And they are not, private IP addresses are not routable to the internet.
Okay. So
So
how do the companies get this private address? Because I'm sure, so from the simple explanation, say IP range 10.0.0.0
mhm,
to 10.255.255.255,
mhm.
all all the companies can use all these range, and all the companies can have any IP from this whole range. So who gives, like, how do the companies buy this, or how do they get to use this in private network?
No, private addresses are not given by anyone. You can use internally inside. You can use anything.
So how do you assign, when you're not buying anything, how do you just assign the numbers like that?
That's why, because these addresses are not routable, right? So whatever you are using inside of your network, it will
Uh-huh.
be inside of your network only. It is not going outside, right?
Okay.
So now you will, let's say you decided that okay, I want to use 192.168, or you want to use 10.0 network, or you want to use 172. So we'll discuss about the private and public range.
Hmm.
But whatever network you are using inside as in private, right, you can use, and these IP addresses are not routable to the internet. So in fact, outsiders, they don't know what you are using. So
So
they,
basically, the network team in the company will decide what range they want to use for private, and then they will start assigning these
I,
numbers to the devices.
correct, IP addresses to the devices, right? And from IANA, this particular IP will be allocated to the regional, internet registries, like based on the continent basis. And then
Okay.
from RIR or from continents, it will be provided to the service providers, different service providers. And from service provider, it will be given to the end user.
These are for the public, right? Not the private.
These are for the public, correct?
Okay.
Because as I told you, public you can, private you can use whatever you want to use inside,
Mhm.
right? So let me new slide. So there are total 5 classes in the in the IP address, IP range. But initially we have 32 bits, right? Total 4 octet. So if I say 0.0.0, which means here I have 8 bits, 8 bits, and 8 bits,
Okay.
right? So if let me take particular one as an let me take one octet as an 8 bits. So if all 8 bits 8 bits are off, right? If it is 0, in that case the value of 8 bits will be 0, right? Because all bits are off.
Right.
But if it is all bits on, right? In that case, each value from left to right, sorry, from right to left, from left to right, they will have a value. So first, like first bit will have 128 value, right? And then second will have 64, third will have 32, and then
Right.
16,
8,
8,
2.
4, 2, and 1.
Okay.
So consider this. So if all 8 bits are on, right? So in that case, what the value you are gonna get?
255.
255. Because if you add all these together, you will get the 255. So which means the IP range will be between from 0 to 255.
Right.
Right. So now, based on this, we have the classes. So like we have class A, and the range of the class A is from, so 0 is reserved anyways, 0 is nowhere used, right? And when all bits or all octets are on in the IP address, it will actually become 255.255.255.255. So when all bits, all 32 bits were off, the value was 0. When all bits are on, you will get 255. So this
Right.
is reserved. This is called layer 3 broadcast address.
Layer 2.
Layer 3 broadcast address.
Okay.
Right. So we discussed about the layer 2 broadcast, right? Layer 2 broadcast
That's
address will,
FFF.
correct. And this is now layer 3 broadcast address. Means to all the nodes, to all the devices, everywhere in the
Only
network.
only the servers and the clients, not the routers, right?
Everything.
Okay. But
So
if the switch receives this, will it understand that this is a broadcast?
if switch doesn't understand, it will send still broadcast because switch is not understanding this,
I see.
right?
No, because the switch understands FFFF, right, as a
No, switch
broadcast.
understands, yes, switch understands layer 2 information, but in case if switch receives layer 3, where switch is not going to understand, right? But
Right.
switch has to somehow forward the traffic, whatever signal it has received. So in that case, switch will send that signal to all the ports. That is called
Okay.
unknown broadcast.
Unknown broadcast. Okay.
Yes, because this is not known to the switch, but still it has to send out that signal.
Okay.
Right. So now in class A, the range of the class A is from the 1.0.0.0.0 to 126.255.255.255. This is the range of the class A.
Okay.
Right. Now in this actually, we also have some network address and some network bits and some host bits.
Yes.
Right. So in this, the network bits and then host bits and then subnet mask.
Okay.
Right. So in class A, the network bits are 8 and host bits are 16. Sorry, 24. So what do you mean by network bits? Network bits means whenever service provider allocates IP address to the user or to the customer, right? They will actually reserve the bits. So for example, 10.0.0.0. So 10 is reserved by the service provider. You cannot make change. 10 is now the first octet or 8 bits will be reserved for the network, and the remaining 24 bits you can use for the host portion. You can assign the IP addresses. Right. So by default in class A, 8 bits are reserved. The first octet will be reserved for the network portion, and the remaining 3 octets will be for the host portion.
So where is that used, the network portion?
Network is to identify how many,
The first, okay, so the first network is to just to identify the first octet where it is starting from. For example, 1 dot or 10 dot or
correct,
172 dot. Okay.
correct. So
it will actually identify nothing, but it will identify the class of address when the network portion will identify the class of the address.
not exactly the class of the address. Anyways, when you put 10 dot, right, so it will be, you know that, I mean, this is class A. But network bits, where it represents what is network anyways. Network is a group of the IP addresses.
Okay.
Right. So for example, I have given, let's say you have given 10.0.0.0 network to your network. I mean, to your computers, right? And you have given IP address 10.1.1.1 slash or subnet mask or slash 8, which is class A, right? Subnet mask to 55.0.0.0, right? So which means now the computer has got the IP address 10.1.1.1. But what is the, I mean, what is the part of network? What is the network of this computer? The network will be 10.0.0.0. Now this network is a group of computers, group of the valid IP addresses.
Okay.
So instead of advertising individual IP, I can advertise network.
Okay.
Right? Because what happens when we talk about the router will forward the information to the destination based on the routing entries
Okay.
in its routing table. Now if you learn individual IP address, the table will be very big.
Okay.
So instead of adding, let's say for example, you must have heard about this range 192.168.1.0.
Right.
Where was that? Okay, let's say this range, right? And the subnet mask 255.255.255.0. Now in this we have, so this is network. Now 1.0 is network. In this we have 254 valid IP addresses. Means you can assign the IP addresses to 254 machine. The first will be 1.1, 1.2, 1.3, and that way 254.
Okay, so
right? All 254 machine will be the part of network this.
Okay.
So instead of advertising all 254 machines individual, I will advertise this.
But in order to explain that, you need the IP the network address plus the net mask, right?
Correct.
Only then you can come down to the decision that it's 254.
Correct. That is why here we have subnet mask, right? The subnet mask, what it tells you, how many bits are there in the network and how many bits are there in the host. So in this, like if you see 255 to 55 to 55 means 24 bits are in the network and 8 bits are in the host. Means
so,
this particular bit you can utilize for the host portion. IP
okay.
address.
So from any 4 octet, when it is less than 255, which means whatever is remaining is can be used for the host.
Correct. So now that is why in class A you cannot use the first octet for host.
Right.
Because this is dedicated for the network. You can use this rest 3 octets for the host. Right? And like we have class B as well. So in class B, like the range of this is 128.0.0.0 to 191 to 55 to 55 to 55. This is the range of class B. And
I see.
network bit here 16 and host bit 16,
Mm.
right? And in this by default subnet mask will be 255.255.0 in class A. In class B 255.255.0.0, because
Okay. So how come
16,
how come we come down to this one? I like
which
the
one?
subnet mask in both the class. How do we
Because as of now, if you see 8 bits for network means 8 bits are on, all 8 bits in this particular octet all are on.
that 255 tells you cannot use anything,
Correct.
and
255 means all bits are, all 8 bits are on.
so
And if it is on, you see this, right? So you will
right.
get 255.
Okay, so you cannot use that for the host, only for
Correct.
the net.
Only
Now,
for
when
the
you go
network.
down to 16, when you go down to 16,
Mhm.
how do you decide that it is 255.255? Because the address is 128.0.0.0, and then
Because if you see, the network bits in class B are 16.
so how is it decided that that's 16 and not 8?
No, by default, it is decided based on the range itself,
Okay.
right? And in for like in class C, we have the range starting from 192.0.0.0 to 223.255. And in class C, we have 24 bits for network and 8 bits for host.
Host.
Hence, the subnet mask will be dot zero.
Okay.
Right now, this is the overall range of the. We apart from that, we have class D as well, where the range is to 24.0.0.0 to 239.255 to 255 to 55, and that is normally used for multicast. We don't use this range. And we have class E as well, and the range of the class E will be from 240.0.0.0 to 255.255.255.254, and this is for the research and all,
Okay.
right? So this is multicast, it is reserved. This is also reserved, right? So both are this particular, this is reserved and this is reserved. Both are reserved actually. We don't use for the IP allocation. Class D and class E we won't be using for IP allocation. Only we'll be talking about class A, B, and C.
Mm.
Right now, in this class A, we have some. This is, as I told you, this is the overall range. As we started with the 0, right, and we had to go till 255, and
Mm.
at the end, as I told you, 255 is the broadcast address.
Okay.
Right.
Okay.
All right. Now in this class A, as I told you, we have two types of IP addresses, public and private IP addresses,
Mm.
right? So in this class A, the private range is 10.0.0.0, 10.0.0.0 to 10.255.255.255. So which means the whole range of the 10 is
Okay.
dedicated for the private use in
Anybody
class
can use
A.
it internally. Okay.
Yes. In class B, Private will be 172.116.0.0 to
So, so companies from any country in the world can use 10 dot address or 172 dot address or 192 dot address private for their internal, and they don't need any permission from anybody.
yes. And in class C we have private range 192.168 0.0 to 192.168.255.255. So this is the private range, right? This complete range 192.168 is the private. Now, as I told you, here we have network bits, and so let me make this little. So now what you have to remember these ranges actually, that what is the range of class A, what is the range of class B, and what is the range of the class C. Moreover, these actually IP addresses are decimal values, right? But when it comes to the computer, when it comes to the machine or any networking devices, they don't understand actually what is, what is the decimal value, right? What they know is that uh, this is your, this is binary. The all computer machine, they process the binary value,
Right.
right? So you should know how to convert from decimal to binary and from binary to decimal.
I see.
So are you aware of that?
I have a rough idea. So the 8 bit is, for example, 1111. All the 8 are ones
Mm-hmm.
in.
So for
So
example, I have 190 decimal.
hmm,
So what will be the binary of this?
190. So 120, 128. So the left side, there'll be the first
One.
one will be one.
Mm-hmm.
Uh, that's 128. So that's 130. You need 60 more, and then there'll be 1.1.0.0. I think.
So 128 plus 64. So it will become 192, right? So one, and then
Uh,
you can use your notepad.
so first one will give you 128. The second one is 64. There is 192 instead of 190. So how do you remove that two?
No, you don't have to remove it. Yeah, that's what, you don't have to remove it. You have to add it as in, you need 190, right? So
Right.
if I turn first bit on, I got 128. But if
Yes.
I turn second bit on as well, I'll get 192.
192,
But
correct.
I need 190. So I'll do one thing. I will turn it off.
Okay. Now I got it. So then you go back to the third bit and
Sure.
try if the third bit will be so
Sufficient.
192
Plus
plus
32.
32 is 224, and then plus 16 will 240. Okay, then you keep adding and you will hopefully get plus 8.
So 190 is 128 plus 32, right? I got 160, right? Plus
1
16. So
224.
186. 186 I got. If I add now 8, it will go up. So I'll say 0, 186, and I need 4, right?
Mm.
So 1 and then 0. So the value of this, the binary of this will be this. 128 plus 16, sorry, 32, 160 plus 16, 186, and plus 4, 190. This is the binary of 190,
Okay.
right?
Mm. Is there a way to memorize and remember, or is there a quick calculation method where I don't have to bring the calculator?
Uh, yes, quick method is also there, as in,
Like any formula or something?
yeah, I mean like 90, right? So you have to divide 90. So divide by 2. Divide by 2. What you will get in this?
45, 45.
Oh, 1 second. Okay. So we got 45.
Mm.
This. Right. So we have got 45. Oh, sorry, this formula actually I never used though, but there is a formula actually. Let me see, how is it. Mm, Divide by 2, so 190. There is a formula. I'll check once and then
Okay.
let you know.
No problem. No problem. No
I'll check.
problem.
It's not sure actually what is.
Yeah. Because I think for the exam, you need to be able to figure this out.
But the simplest way actually is this one. You have to remember this,
Okay.
right? 128, 64, 32, 16, 8, 4, 2, 1. This actually, I liked it, this
Okay.
formula. And then whatever bit you want, little calculation is required, yes. But whatever bit you want to off, you off it, otherwise turn it on and add it, it will come the total.
Mhm.
So if, for example, if I need 200, right?
Mm.
So I will do one thing. I will add first 128 and plus 64, which becomes 192, and then
Mm.
0, and then 0, because I need now 8,
Mm.
right? So I will turn this bit on and remaining all zeros. 8421. I have
Mm.
got 200 because 128 plus 64, 192,
Mm.
and plus 8.
Mm.
Right, so I 128 plus 62, 64 and plus 8, I have got 200. Rest all bits 0 in between.
Mm. Mm.
Clear?
Yeah.
All right, so let's just stop here. That's enough for today, and
Mm.
we'll continue tomorrow. IP addressing.
Okay. So this is the most